All right, so welcome back to everyone. A very warm welcome to all of you on this beautiful day. We are going to complete the projectile motion, right? So, guys, my name is Dr. Umashankar and I am your physics educator. Okay, these are the brief qualifications of mine. I have completed PhD and MTech from Indian Institute of Technology, Roorkee. I have qualified the GATE examination. I am having 11 years of teaching experience and I have maintained many of the JEE and NEET aspirants. Okay, moreover, I am author of some scientific research papers as well. Okay, so now in the last session, guys, so this is first of all, this is the fourth session in the projectile motion journey. What is it? So basically, we were dealing in the projectile motion, right? Okay, so this is basically the live student. Welcome to the session, guys. I hope you can see me and hear me properly. Okay, right. So we are going to continue with the projectile motion. So guys, please note, this is the fourth session in our journey of projectile motion. Okay, so when you are watching this session, if you are live today or if you are watching it in a recorded mode or later time, okay, please ensure that you have completed or you have seen the first three parts of the projectile motion. You can see them on this channel. Okay, you can search it on YouTube and you will get the projectile motion on this channel, Lean Success Simplified. So before we start with it, so we need to go through the basics of it. Okay, so what we have done till now, so we have done basically we have done in the three parts. So we have seen the ground to ground projectile, ground to ground projectile. Okay, we have seen equation of the trajectory and its use, equation of trajectory and its use, okay, equation of trajectory and its use, and lastly we have seen projectile from a height, projectile from a height, right? So in the case of this, we have done till this point. Okay, in the case of projectile, we have done till this point in the previous session. So what we got to do in this session? So basically, we are going to deal with the projectile motion on the inclined plane. So in this session, we'll be talking about projectile motion in an inclined plane. Okay. So we are going to talk about the projectile motion in the inclined plane in this very session. Okay, now let's see. So first of all, giving you a little revision of what we have done. So see, what we have learned. So whenever we are dealing with the projectile motion, basically we have to see, or this is a motion in a plane, that is motion in two dimension, and we need to see this motion by breaking it into two parts, that is one in the horizontal direction, another is the vertical direction. So how we deal with this projectile motion, sir? We divide or we see the motion in two different directions, and hence we you know deal with this motion. So see, let's suppose a projectile, a particle is thrown or particle is projected at some angle of theta from the horizontal, and we are having this. This is y direction, this is x direction, right? This is y direction and this is x direction. So when we are moving, when we are doing it with the velocity of u, when we are doing it with the velocity of u, and we are doing it with some particle with the angle theta. So see, in this case what happens, so we are going to break this velocity in x and y direction. So what we do, so this is u cos theta, this is u sin theta, and we understood, see, when we are separating this motion in x direction and y direction, we are going to divide this motion in x and y direction. So in x direction, what is the initial velocity? It is u cos theta. It is u cos theta. What is the acceleration? So it do not have any acceleration in x direction, right? Then in y direction, it has initial velocity of u sine theta, and in y direction, the acceleration is minus g because gravitational acceleration always acts in the downward direction, right? And the downward direction in our journey, we have considered it as negative direction, right? We have considered it as negative direction. So we have x direction, we have y direction. We have x direction, we have y direction. So now once we separate the motion of projectile in these two very dimensions, that is x and y direction, then what we have to do? We have to do apply the equations of motion. Okay, so afterwards we separate this motion in x and y direction. We need to apply equation of motions in these two directions. So what are the equation of motion? So v is equal to u plus at. Okay, s is equal to ut plus half a t square. Okay, and v square is equal to u square plus 2as. So by considering the motion in x and y direction and using these equations, we have found the time of flight, the maximum height, and the range. Right, Buddha? Right, Buddha? Please answer me. The live students can respond. The live student can respond to me on this. Okay, wonderful. Okay. So now this time, what is the time of flight? So the time when it is projected till it reaches this point. Okay, that is what we call as the time of flight. Okay, what is the height of maximum height? So see, in x direction there is no acceleration, so x direction velocity or speed remains constant, whereas y direction speed keeps on decreasing. So when the velocity in y direction becomes zero, at the moment the velocity in y direction becomes zero, the projectile attains the maximum height. That is your h. That is your h. Okay. So projectile reaches the maximum height, that is your edge, and afterwards it follows a descent. Okay, and this is your range, right? This is your r, that is your range. So when you consider the motion in x direction, you get your range, right? So this is how we approach. This is how we are seeing the things. This is what we have done till now. Now in the same process, we have dealt. Yeah. Okay. Okay, very well. Now let's proceed. So now in this session, we are going to deal with the projectile motion on inclined plane. So are we going to do anything new, sir? No, sir. We are going to do the same thing only. So projectile motion on inclined plane. Now please understand this. See, so this is your inclined plane. This is theta. Okay. Now, please understand this. See, what we are going to do, we are not going to do anything new in this session. See, projectile motion on inclined plane, you have to use a little of, you have to use here a little of equation of motion, right? We have to use a little of vector and we are good to go. See, please understand this. See how we are going to do it. See, there can be several ways of solving this question. So let's suppose firstly, let's consider. So when we talk about projectile motion, projectile can be a particle can be projected from bottom to top. Hello Shishai, welcome to the session. How are you doing? Okay. So we are dealing with the projectile motion on the inclined plane. So this was left. And after this session, I have planned another session of relative velocity in 2 dimension. Okay, so relative velocity in 1D we have seen previously. Now today at 5 p.m. I'll be completing the relative velocity in 2D also. So we have 2 sessions today. Okay, and by the way, happy Diwali to you guys. Today is the Choti Diwali, right? So happy Diwali to all of you. Okay, so now projectile motion can be of two types. One can be down to top. Okay, so again, I'll not take it as a topic or something since it is in the NCRT, since it is in your book. I don't consider this as another topic. I consider it as a question of the motion under the gravity. The whole of this, projectile motion is nothing but a case of motion under the gravity, kind of question of motion under gravity. Okay, she's saying. Great. All of you must be happy early. Okay, so let's consider firstly top to down to top. That means we are having the initial velocity. Let's suppose we are having a projectile like this. So u, this is let's suppose alpha. Okay. And when we talk about the top to down, so it can be like this u, and this is going to be alpha. Okay. Okay. So now let's consider this one first. Down to top one. Okay. Now see what we got to do here. So now when we are projecting something at a velocity of u, let's suppose at an angle of alpha from the inclined surface, now what is going to happen? So it is going to follow a path like this, right? And it is going to be falling at some, distance like this. Okay, distance like this. Now see, when we were dealing with the resolution, when we were dealing with the vectors, I told you a case of inclined plane, right? So see, resolution of vectors. So that is why I always say that the vector is very, very important. It is basically applied in all the concepts, most of the concepts of physics, right? So now here you see there is an inclined surface. So whenever you find an inclined surface, I always advise that you forget about x and y. Okay, you consider everything on the plane which is you consider the axis which is parallel to the inclined surface and the axis which is perpendicular to the inclined surface. Okay, so let's suppose this is x and this is y. This is x and this is y, right? And this is thrown at an angle of alpha. So what we have done, so instead of taking horizontal and vertical axis as x and y, I have shifted the whole scenario. Okay, I have considered one x in the direction parallel to the inclined plane, and there is y which is perpendicular to this inclined plane. So we have just shifted this axis x and y. So x and y is like this. Okay, we have shifted it. No problem at all. Okay, now forget about the horizontal and vertical. Now what we are going to do, let's see. Now we are going to do the same thing. We are going to apply the equation of motion. We are going to do everything in the same manner. See, now I am going to take the component of it of u in x and y direction. So I'll be taking the component here. So this will become u cos alpha, isn't it? Do you have any problem with it? No, sir. And this is u sin alpha. I don't think there would be any problem in this. Right. Now, if I talk about this x and y direction, so what is the motion? Let's write the motion as always. So in x direction, in y direction, what do we have? Now in x direction, what is the initial velocity? So in x direction, in this x, remember we have shifted this whole x thing. So in this x, we are having the initial velocity of u cos alpha. Okay, in the y, we are having the initial velocity as u sine alpha, as u sine alpha, right? Now in x direction, in this x direction, the acceleration is going to be what? Is it going to be 0? Is it going to be 0 or not? Please answer me. Is it going to be 0? Is it going to be 0 in x direction or not? Please answer me. What do you say? Is it going to be 0 in x direction or not? As always. So, sir, no, sir, this is not going to be 0 in x direction because now x is not horizontal direction. Yeah, no, it is not g cos theta. I'll tell you what it is. Is it the but first of all, please try to understand that this is the only difference in inclined plane and the horizontal ground to ground projectile or projectile from a tower. That it also has the acceleration in x direction and we have shifted the x. That is not the x which is horizontal. If you are having a problem in this like x and y, if you are getting confused, you can name it anything n and m. You can name it n axis, m axis. Okay, so we have named it as x axis. So here, remember one thing here: ax and ay are not the same as we have seen in the ground to ground projectile motion. So what it is going to be, please understand this. So this is your inclined theta. Okay, and this is G. So this is going to be what? This is going to be G sine theta and this is going to be G cos theta, isn't it? How come, sir? So we have dealt it in the resolution of vectors also. If you remember, see, if this is theta, this is 90, this is 90 minus theta. So this is going to be theta. So you know that in the direction of theta, it goes like this G cos theta and in this it goes like G sine theta. Now what is the AX? So sir, it is going to be minus G sine theta. Sir, how come you are taking it as minus? Because obviously this direction is positive direction we consider. Now we have seen the sign convention also. Okay, so if the velocity also tells us the direction of motion, isn't it? So when we say when something is having a velocity along the positive x-axis, we consider it positive. When it is having a velocity in the negative x-axis, we consider it negative. So here ax is going to be minus g sine theta because this direction of acceleration is in the direction opposite to the velocity in x direction, or you can say positive x direction, whatever it is. So ax is going to be minus g sine theta. And what is going to be ay? So ay is going to be, that is this, in this direction. So it is going to be minus g cos theta. Again, why minus? Because I can see it is downward. Right? Do you agree? All of you? Agreed? Okay. So see, once you have this thing in x and y direction, now everything you can find. Right? Now please tell me the time of flight. So what we have to find? So as always, sir, please give me time of flight. Right. So I don't recommend that you always remember the formula of each and everything. Okay. But to save times, at times we have to also. But in these all cases, you don't need to actually. Right. Because see, if you think a little, you will be able to get the formula or you will be able to do the question. Right. Now, can you give me the time of flight? This is what we get time of flight. How we are going to get it? The time of flight. Please answer me. So how did we derive the time of flight previously? So we considered the motion of y direction, right? Yeah, we'll see. So we have considered the motion of y direction. So when we consider the motion in y direction as always, so I can consider it from, let's suppose this point is A, this point is B, this point is C. Okay, so I can consider it till C point, or then I can consider it till B point. So let's do till A to B, from ultimate initial to ultimate final. For ultimate initial to ultimate final. Okay. Okay. So what is going to happen? So from ultimate initial to ultimate final, that is A to B. So what is going to? So we are considering the motion in y direction. So Sy is equal to Uyt plus half Ay t square. Okay. Now in this case, what is going to happen? So Sy is 0. Okay, what is the displacement between A and B in y direction? So it is going, and what is your y? Y is not your perpendicular direction, but it is perpendicular to the plane of the incline, right? Now in this case, this is going to be 0. Uy is going to be u sine alpha, and let's say the time of flight is t. So please take care of the sign also. Minus 1 by 2 g cos theta t square, g cos theta t square, right? Yeah. Okay. So yes, Ay is minus g cos theta. Okay. Now we have placed it here. So what we are getting at? So t u sine alpha minus g by 2 cos theta into t, right? So from here t is 0. So t is 0, that is, it is showing you the initial position, and the other one is t is equal to u sine alpha 2u sine alpha upon g cos theta, right? Is it fine or not? Please answer me, right? Okay, okay. So it is very much similar to what we have seen there also, na? Ground to ground. There it was 2u sine theta. So there the angle of projection we have considered as theta. Here we are considering as alpha, right? So it was 2u sine alpha upon the acceleration in y direction. So here the acceleration in y direction is g cos theta. So that way you can memorize it. Now get me the maximum height, that is h. Please get me the maximum height. Yeah. Shrita, you need not to remember the formula of the range. That is I was going to come about. See, the range formula is quite lengthy here. There is no need. You can do it. I'll tell you how to do it. Don't worry. Now coming to the maximum height thing. So what is the maximum height? Okay, let me copy this image to this. See, there is absolutely no need of remembering the formula. Okay. Okay. Now please observe. Please observe. Now, what is the maximum height here we are referring to? So this is the h we are referring to now, because h we are considering from this, plane, that is our x. Are you getting my point? Now, if at all they ask you from the ground, you can use some geometry and can get that. I don't think that that would be a big problem. No, will that be a big problem? No, sir. We'll use a little bit of geometry and we'll get this height if asked from the ground. Right now, what is this going to be h now? Please understand this. So see, again, we are going to see the motion in y direction, and let's consider the motion between A to C. Now, whenever guys you are applying the equation of motion, be very clear, be very, very clear that you are going to be very, very clear. You are going to be very, very clear that you are going to use the right formulas, the right of first sort out that from which point to which point you are applying the motion equation. So from A to C we are applying, right? Now when we are applying from A to C, what is the initial velocity in y direction, sir? Initial velocity in y direction is going to be u sine alpha, right? What is the acceleration in y direction? It is minus g cos theta, right? What is the final velocity in y direction, sir? This is zero, because that is why it, yeah, you can derive, okay? Range you never memorize. See, I never recommend you memorize the range, such a big formula, no? Why unnecessary occupying your space, right? And in the NEET examination also, she said this is a fact that this is not a very frequently asked problem, isn't it? Normally, ground to ground, they keep themselves to ground projectile. Very rarely they ask you this, isn't it? But although we can't take risk, but see, memorizing everything in physics is not the solution. Then what will be the difference between this and biology, right? So Vy square is equal to Uy square minus plus 2a sy, right? So this is going to be 0. This is uy, that is u square sine square alpha, and this is going to be minus 2g cos theta, 2g cos theta of h, 2g cos theta of h, right? 2g cos theta of h. So from here we'll get h is equal to u square sine square alpha upon 2g cos theta, upon 2g cos theta, isn't it? Right? Okay. Yeah. 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 That is what I am saying, she said. But still we must know. See, so this is fine now. H is equal to u square sine square alpha 2g cos theta. Fine only. Now again, see, if you want to memorize the formula, even if you like memorizing, then see, T is equal to, so in the ground to ground projectile, 2u sine alpha upon g it was, isn't it? So basically g is what? Acceleration in y direction. So in this case, the acceleration in y direction is g cos theta. Now h is also u square sine square alpha. So this is the same thing. In there also ground to ground projectile. Upon there it was 2g and it was 2g cos theta. So that is g cos theta is equal to y. Understood, Buddha? Please answer me. Will please answer me. Right? So you can remember it this way, that a time is, see what I used to do in this case. I'll tell you what I do. Okay, so I remember that the time is 2u sine alpha, that is 2 times initial velocity of projectile in y direction upon acceleration in y direction, right? Now, similarly, height is square of velocity in y direction upon 2 times g cos theta, that is 2 times acceleration in y direction, right? So if you want to memorize, you can memorize. Now I would write it here also. See, everyone teaches according to his belief. So I believe that don't memorize the formula of range in this case because it is too long to remember. Don't memorize. Okay, according to me, you must not memorize. So sir, how we are going to get this r? So we are going to get it from the basics. So ux here is we have u cos alpha, right? Ax here is we have minus u sine theta, because you memorize for this one, then you are going to memorize for top to down motion. How much you are going to memorize? Then this is not feasible. So what we are going to do? Oh, minus g sine theta, I must write. Minus g sine theta. Now we have ux, we have ax. So now consider the motion from very initial to very final. So the range is going to be, this is going to be ut, that is u cos alpha. Now time, when we have this formula already, so time we can calculate, this would be a number. In a question, this is going to be a number, right? So you are going to put a number here, isn't it? You are going to put a number here. Okay. Okay, so I'll write this way even. So uxt plus half a t square, ax t square, isn't it? What is the problem? We'll do from here, isn't it? Is it fine? But please answer me. Okay, we are not going to memorize. If you want to develop a formula, you can definitely do. Okay, so from here, if we develop the formula, we are going to get something like this. R is equal to 2. So when we do some geometry, when we do some trigonometry, when we put the formulas and everything, we are getting this expression 2u square sine alpha upon g cos square theta, okay, and cos alpha plus theta, right? When you derive it, when you put this value of ux, then you put this value of capital T, then you put this, so this T is capital T. Okay, so when you are going to put everything in this equation, you are going to get something like this, which is not at all, I think, feasible. Don't memorize it. That's all. Okay, clear? Okay. So now when we are dealing with the down to top motion, we are going to find the range, we are going to find the height, we are going to find the time. So let's do some questions here. See, very, very simple. Huh? Let's suppose something is projected at a velocity of 10 root 2 at an angle of 45 degree, and this is 37 degree. Okay. Okay. Now please try this. Okay. I want everything. Right. I want T, I want R, I want H. So whatever. See, in a question of projectile motion, what else can be asked? Please go for it. Correct. What are we going to get as time, height, maximum height, and range? Please. doesn't seem correct. Time doesn't seem to be correct. I think you might have made some calculation mistake. Let's see. Now, sir, we just have derived the formula. Even in the examination, you forget the formula. I think you can find your answer. So, T is equal to 2u sine alpha, 2u sine alpha upon g cos theta. And when you are remembering the formula also, na, acha, acha. So, 2u sine alpha upon g cos theta. Now, what is going to be 2u sine alpha? So, remember when you are remembering the formula, na, so also remember that what is alpha, what is theta, right? I have considered this as alpha, na, and this is theta. I'll solve it. So, now what is going to happen? So, this is going to be 10, 2 into 10 root 2, and this is going to be sine alpha, that is sine 45 degree, upon this is g G, that is considering it as 10, and cos 37. So cos 37 is 4 by 5. You know, remember the standard triangle. So if this is cos 37, so cos, don't worry, Trisha, it's okay. So I'll solve, don't worry. So it is going to be how much, Vida? It is going to be, see, this 10 cancel out, this root 2 cancel out. So it will become 10 by 4, isn't it? 10 by 4 second, that is 2.5 second, right? Now, similarly, we can have the h. We just have derived it. So h is what? U square sine square alpha upon 2 times g cos theta. Okay. So h is going to be u square. So that is 10 root 2 square. Okay. Sine square alpha, that is sine 45 square. Sine 45 square upon 2 times g, that is 10, and that is cos theta, that is cos 37, that is cos 37. So it is going to be 10 square, that is 100, into root 2 square, that is 2, sine 45, that is 1 by 2, sine 45 square, that is 1 by 2, isn't it? Okay. And this is going to be 2 into 10, and cos theta is what? Cos theta is 4 by 5 in this case. So this is going to be 2 to cancel out. 2 and 2 will be cancelled out, and this is going to be how much? This is going to be, so see, 2 cancel out, 10 by 2, that is 5, and 5 25, 25 by 4, isn't it? 25 by 4 meter. So here it was given in meter, right? Okay, so we have, so unit I haven't mentioned, let's suppose it is meter per second, it could be anything. So I think you understand, na? So this way I'm doing the question. Right, I'm not going to write the whole thing, and I'm just trying to give you the concept. Question, you can do any numbers, isn't it? Now coming to the range we do not remember the formula. So finding out the range in this case, what we are going to do? We are going to consider the motion in x direction. Okay, what is the x in this case? So our x is this. This is our x. Okay, this is our x. So this is going to be x direction velocity, that is 10 root 2 cos 45. 10 root 2 cos 45. Okay, and our acceleration in x direction is minus g sine theta. So that is, let's write it, minus g sine theta, that is sine 37. Now what is going to be the range? So range is going to be ux, that is 10 root 2 cos 45. Okay, now time we already have calculated. See, time is what? Time we already have calculated 2.5. So let's right away put 2.5 now. Okay, what I'm doing, I am applying this equation. Sx is equal to ux plus half ax t square. Right? Okay, so in this case, see, 10 root 2 cos 45, time is 2.5 plus, also I'll do it as minus once we put. So minus half ax, this is 10. Sine 37 is what? Sine 37 is 3 by 5. Okay. 3 by 5. Okay. So minus half g, and g is 10 sine 37 or t square. Okay, so t is 2.5 square. So see how simple it is now. Instead of memorizing that big formula, when it is not looking like that big right now, because when you are putting the values, time is a value. Okay, so when you obviously when you solve a question of projectile, the first thing that you get is the time of flight. Once the time of flight is found, you are going to put the value there, and then you are going to get the answer very easily. What is the need of memorizing such a big formula? Are you getting my point, guys? Okay. Now, when we calculate it, okay, so let's calculate it then. So this is going to be 10 into 2.5, that is 25. Okay, 10 into 2.5, that is 25. This is going to be see 2 cancelled out, so it is going to be 3 into 2.5 square. Okay, so 3 into 2.25. Uh, okay, okay. So afterwards, when we calculate it, I think we are getting 6.25 meter. You can cross check it once, right? Is it easy or not? Please answer me. Do you agree or not? Please answer me. Yes or no? Please give me yes or no. There is no need. What is see? You can always choose your way. One way can definitely be that you remember this formula. But when I see this formula, na, 2u square sine alpha upon g cos square theta cos alpha plus theta, right? I feel dizzy. See, my way of learning and my way of teaching, and the way I have learned the thing, see, it is very hard for me to memorize things. Are you getting my point? I am not very good at memorizing. Even today, after teaching 10 years of physics, even today, till today, I keep forgetting the formulas. Are you getting my point? Right. So, see, this obviously depends upon personality. Okay. So, I don't recommend, memorizing everything in physics, particularly in physics. There's no use, according to me. There's, you can do yourself. Now, let's see one more question then. Let's suppose this angle is 37 degrees and something is thrown at an angle of, let's say, 10 meter per second, and this is thrown at a 53-degree angle from here. Now you can find the same thing. Huh. So time, height. So what is the best way? See, when we are memorizing, yeah, this is too long a formula. So what we can do, we can find simply the t, and afterwards this is very easy. No pain in mind. Now let's try this one. Let's try to do this one. Let's see if we can do it or not. Please try it. I'm very sure we can do it. No problem at all, Bida. Because hello, welcome to the session, my dear. I am Dr. Umashankar and I am teaching. Yeah, because my name is Dr. Umashankar. Yeah, this is my name. So, welcome to the session, my dear. And what we are trying to do here, we are trying to uh, take a journey. Yeah, you have come to. So, this is a new channel basically of Unacademy. and this is an English channel. So here I am teaching the physics part. Okay, my dear. So on this channel till now, what we have completed, so we have done this. Uh, so meanwhile, the rest of the students, please keep solving the question. Yeah. So basically on this channel, we have completed the units and measurement in physics, and then we have started with the kinematics, and we have completed the motion in a straight line. Okay. And now we are approaching towards the completion of motion in a plane. Along with, I have given you complete vector thing also. So that is what we have done till now. Okay. And afterwards, after this motion in 2D, we'll be starting with Newton's law of motion. So after this, one topic is left, two topics are left basically of this particular chapter, that is relative velocity in two dimension and circular motion. So relative velocity in two dimension, I'll be completing today itself at 5 p.m. We'll be having another session. And after that, we'll be starting with circular motion, most probably from tomorrow. Okay. So this is how we proceed. And on this channel, biology is also running. Sir is taking the biology. Chemistry is very soon is going to be started. Yeah, because we are completing all the chapter on the basis of new syllabus, which is actually old syllabus only, right? So hardly anything change in physics. Okay, don't fall in those traps. This is my recommendation to you. I have given one video also on this, the complete syllabus thing. That there is almost nothing has changed. Okay, in physics particularly. So we are trying to complete the whole syllabus. Okay, by the end of the March. Okay, we are trying to do so. Okay, but see, there are many limitations. Now Diwali has come. Okay, many things happens in between. Okay, so let's see. We are trying to do as much as we can. Okay. Now see, this is 10 meter per second. This is 53. This is 37. Okay. So very simple. Huh. So yeah, R can be found through logic, right? Okay, it can be found through logic also. But like if you want to go with the formula, so what is the time of flight? Okay, so how we are going to see the time of flight? So time is 2u sine alpha upon g cos theta. Because yeah, see almost note. See, I'll see. I have explained the whole thing in one video also. So see, if some topic is not written at one place, it is in a way written at another place. This is what I felt after seeing this syllabus. Okay, and some topic which are not mentioned, like rolling motion is not mentioned, but rolling friction is mentioned. How can you study the rolling friction without rolling motion? So these kind of things happened a lot in this way. Okay, so we must not take the risk. This is what my recommendation to you. Rest it is up to you. Okay. So see, let's move ahead. Okay, so I'll be putting everything here. So what is 2 u? U is 10, sine alpha, alpha is 53. So because you may come to the live sessions also, you may watch the recorded also. And if possible, you can subscribe the channel so that whatever new videos are going to be on live, you can have the notification of the same. Now this is going to be 10 cos 37. Okay. Now again we can solve it, and when we solve it, I think we are getting 2 seconds. Is it? Okay. 2 seconds. Right. Now similarly we can find the height also. Height is u square sine square alpha upon 2g cos theta. Okay, this is the formula. So u is 10 square sine square alpha, that is sine square 53, sine square 53 upon 2 into 10, yeah, into cos 37. यार भाई सर सिंपल हार्मोनिक समझने को के लिए अच्छे से ट्रिग्नोमेट्रिक फंक्शन आना चाहिए। देखो यार बहुत अच्छे से, मतलब अब देखो नीट लेवल पे ईमानदारी से बताऊं, बहुत ज्यादा डेप्थ में मत जाना किसी भी मैथमेटिक्स की। आप मैथ्स को ऐसा पढ़ा करो ना, मतलब अगेन मेरा सजेशन है, देखो काइनामेटिक्स इंटीग्रेशन, ये जितनी मैंने पढ़ाई है आपको इस चैनल पे, आप उतना पढ़ लो, उससे ज्यादा नहीं लगती है। ठीक है, सिंपल हार्मोनिक मोशन में आपको थोड़ा डिफरेंशिएशन भी लग जाएगा, ठीक है, लॉजिक लगेगा। और देखो पढ़ते पढ़ते ना जितनी ट्रिग्नोमेट्री मिलती जाए उतनी उतनी करते जाओ, अलग से मत पढ़ने निकलो ट्रिग्नोमेट्री की, लो मैं पहले ट्रिग्नोमेट्री पढ़ लूँ, उसके बाद मैं सिंपल हार्मोनिक मोशन करने जाऊँ। So Kushal, I think Kushal, this channel is for NEET. Okay, so I think those who are coming to this channel have already chosen the field. Although if you are also if you are like asking in general this question and you want my opinion on this, see my in my opinion, see you must do what suits you. You must see your capability. Okay, you must see your surrounding. Okay, you must ask your friends and parents about this, that what stream I may go in and what is the career scenario. Okay, I tell you one thing from my experience. Okay, I have seen that the students or my friends, my seniors who have interest in some stream, they worked really good in those streams. Okay, यार देखो, आपसे एक बार मैंने पहले भी कहा था, देखिए जब आप कंपटीशन के लिए दोस्त इजी एक्सप्लेनेशन, जो भी आपका नाम हो मेरे भाई, देखिए जब आप किसी कंपटीशन के लिए पढ़ते हो ना बेटा, तो आपको ना उस समय मजा नहीं लेना है, आपको कंपटीशन क्रैक करना है पहले, मजा उसके बाद लेना है। गेटिंग माय पॉइंट? पहले कंपटीशन क्रैक कर लीजिए, उसके बाद जिंदगी पढ़िए भाई, पढ़ते रहिए फिजिक्स, कोई दिक्कत नहीं, कोई नहीं रुकने वाला, ठीक है। और फिजिक्स में उसके बाद सब आपकी वैल्यू भी करेंगे। अभी आप दुनिया भर का पढ़ लोगे, नीट निकलेगा नहीं, वैल्यू खत्म हो जाएगी आपकी। मतलब टाइम बीइंग, ऐसा नहीं है कि नीट इज एवरीथिंग, आई टेल यू ऑल, ऐसा भी होता है। सी दोज हु आर नॉट इनटू एनी एनआईटीज, आईआईटीज, एम्स, इट इज नॉट दैट दे आर नॉट परफॉर्मिंग वेल, दे आर also performing well यार, ऐसा नहीं है। they may exceed even an IITN or something, ठीक है, but time being when you are trying to crack something, so obviously you want to crack it, isn't it? That is why you are watching my face now on YouTube. There are so many things that are available on YouTube, you are watching my चढ़ा हुआ face, isn't it? है ना? You can go watch anything you want these days, right? So you are watching me because you are having a target in your mind. Okay, so we don't have to do like this in a competition. Don't diverge, always converge. Right, so let me converge now. So see, H, when we are making the calculation, I think we are getting this 4 meter. And what is going to be the range? So see, you can do it by the simple logic also, or you want to go with the formula also. So see, if you see 37 plus 53, it is nothing but 90 degree, no? Arif, okay, yeah. Arif, wonderful. So it is 90 degree. So Arif, these all are just the suggestions. See, I always believe the only difference between me and you is of first of all the age, and the second of it that these things I have read sometime before you. That's all. I'm not like any master. I'm not like god of anything. Are you getting my point? Just a simple common person, a simple common teacher, right? And the only difference is that I have studied this before you. And it is also not like that I have done everything right in my life. Are you getting my point? I have made my mistakes and I keep doing it. Right? Are you getting my point? So I can suggest you only. The rest, always, all of you, this is my, humble request and advice as a senior to you, as a brother to you, that don't fall into this. Now, he says that teacher said this. Don't trust anyone blindly, not even me. Right? Whatever I'm saying may not works for you. Understood? ओके, कि मैंने ऐसा किया, आप भी ऐसा करो तो ऐसा होगा, कभी इन चक्करों में मत पड़िए, फाइनल डिसीजन खुद लीजिए, गड़बड़ होगी तो ओनली यू आर रिस्पॉन्सिबल, अगर सही हुआ तो बेटा सब क्रेडिट लेने आ जाएंगे, ठीक है। अभी आप में से रैंक आ जाए, या श्वेता, यस आई एम मैरिड, तो अगर आप मान लीजिए आपकी रैंक आ गई तो सब लोग खड़े हो जाएंगे, अरे मैंने भी पढ़ाया, उमाशंकर सर भी आ जाएंगे, हर्ष सर भी आ जाएंगे, है ना, कि अरे हमने पढ़ाया तभी हुआ। अरे ये सब बेकार की बातें हैं यार, ठीक है, कुछ नहीं होता ये सब, आपको अपना डिसीजन खुद लेना है, ठीक है। यू हैव टू टेक योर ओन डिसीजन, यू कैन टेक एडवाइसेस, but you have to always critical analysis, or you always have to do the critical analysis of that advice. This is my advice to you. Rest upon you again. Now see, this is projected at an angle of 90 degree. When it is projected at an angle of 90 degree, guys, so obviously this is going in a vertical direction, is going to fall at the same point, right? So R is going to be 0 anyways, but if we want to find it, what we can do, sir, we can go by the basics. So it is UXT plus half AX t square. The only thing, just keep in your mind that you are going to apply for finding the range, you are going to apply the motion in X direction. Okay. So what is this UX? So this is UX is going to be 10, okay, 10 cos alpha, that is 10 cos 53. Okay, what is the time? Time we already have sorted it out. So that is 2 seconds plus half, okay, AX. So this is minus of G sine theta, that is sine 37, right? And this is T square, that is 2 square. Okay, that is 2 square. So from here we are getting what? So from here we are getting this as 0. When you calculate it, we are going to get a 0. Are you getting my point? And like without even solving it, we could reckon that this is going to be 0 only, because this projection is 90 degree from the ground. So this is kind of a vertical motion only. Understood, Bida? Please answer me. Bataiye. So this down to top motion is done of the incline. Hmm? One kind of a question they may ask also, one more type they sometimes ask you what they ask. So they ask you, like, let's suppose something is projected like this at an angle of alpha, this is theta. Now if it is strikes the surface, it strikes the inclined plane or inclined surface at 90 degree, that is it falls perpendicular to this inclined surface. What is the relation between alpha and theta in this case? Relation between alpha and theta. Can you tell me that? What is the relation between alpha and theta? Can you tell me? Yeah. Tell me what is this going to be? Please go for it. I'm very, very sure we can do it. Any answer to that? What is the relation between alpha and theta? Very, very simple, is it? What is the problem in it? What about the rest of you? If anyone else can answer me, see, very simple. Yeah. What get wrong? So see, it is projected in a way that it fell perpendicular to it. So this angle is 90. That means that u is 90. Okay. This velocity is 90. So now this is 90 degrees. So at 90 degree, there is no component of the velocity. Any vector do not have any. Our vector don't have a component in its 90 degree direction. Do we know it or not? Please answer me. A component do not have a component do not have a component perpendicular to its direction, isn't it? Hmm? No, 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 no. Doesn't work that way. So what is it? See, what is the problem? So can we write Vx is equal to Ux plus Ax of t, right? Ux plus Ax of t, isn't it? Now, what is this Vx? What is the final velocity in x direction? This is going to be 0 because it fell perpendicular. So when it fell perpendicular, so the x direction velocity is going to be 0, isn't it? Please answer me. Yes, sir, of course. Okay. Now, what is this ux? The ux is u cos alpha. Okay. U cos alpha. What is this ax? It is minus g sine theta. And what is this t? So t is obviously the time of flight. So time of flight is 2u sine alpha upon g cos theta. Upon g cos theta. Now from here, see, can I write it like this? So u and u will be cancelled out and we can write it like this. So see, it will go like this. So cos alpha is equal to see sine theta cos theta. So it is going to become 2 tan theta sin theta cos theta. It will become tan theta. This sin alpha, I'll take it here. So it will become cos upon sine 2 tan theta. Cos upon sine 2 tan theta. So this will become cot alpha. This will become cot alpha is equal to 2 times tan theta. Please tell me if it is fine or not. Please answer me. Yeah. Right. So this is the relation of theta and alpha in the case when the projectile fell at 90 degree to this inclined plane. Is it fine, Muda? Please answer me. Yeah. Yes or no? Yes or no? Or shall we complete? So this is down to top motion. You can do n number of questions, but I think the concept is sorted. Yes. Now can I come down to top to down motion? Can we go to top to down motion? Now normally this top to down motion is given like this. Otherwise, I hope projectile motion is clear to everyone. Questions are very frequently asked from this. Sometimes I cannot make the straight line. This is the straight line, okay? Now, in this case, what happens? So, top to down motion, let's suppose something is thrown like this, okay? Something is given and motion like this, and this angle is alpha, and this angle is theta. This angle is theta. Now, in this case, what is going to be the difference? So, sir, obviously, this is projectile. This projectile is going to follow a path like this. This projectile is going to follow a path like this and it is going to strike down somewhere here. Okay, is it fine? Right? Now, sir, what we do, sir, as soon as we see an inclined plane, if it is in this topic, when we are going to the next topic, also in the case of friction and everything. Okay, in the case of friction, everything, in that also, see, whenever you see the inclined plane, you always do one thing. You consider x and y along and perpendicular to the inclined plane. So this is going to be your x, this is going to be your y, right? Just in the same way. Now, see, so just keep this thing in your mind. You will never going to make any mistake. That to deal with the projectile motion, see, all or I must say, like in a whole motion in a plane, we are going to do the same thing. We always break down the motion into this two, that is x direction, y direction. Are you getting my point? So we are going to do the same thing here again. In I'll be teaching you relative velocity in 2D also, like in some time. Today only we'll do that. So in that also you are going to see that we are breaking the motion in x and y only. The same way we do always. Okay. Okay. Now this is x direction, this is y direction. So what is going to happen, sir? In x direction, what is going to be the initial velocity, sir? So in x direction, the initial velocity is going to be u cos alpha, right? In x direction, the initial velocity is going to be u cos alpha, okay? In y direction, the initial velocity is going to be u sin alpha, okay? U sin alpha, okay? Now in x direction, what is going to be the acceleration in y direction, what is going to be the acceleration. So in y direction, the acceleration, please tell me what is going to be the acceleration in x and y direction. What is going to be the acceleration in x and y direction? Can you tell me that? Please answer me. So sir, again we have to do the same thing only. Neha, no beta, this doesn't work this way. Neha, this is not the horizontal direction x, na? I think you are confusing it with ground to ground projectile or projectile from the tower. This is what I have explained. So this is the fourth video of projectile motion beta. Okay. So please, because I'm almost at the end of the session, so it is not possible for me to, give you the whole flashback thing, but you can watch the session. See, in this case, we have shifted our x. The x is not the horizontal x and the vertical y is not the vertical y that we consider usually. Here, x is parallel to the plane of incline and y is the x is perpendicular to the plane of the incline. Okay. So what happens? So this is going to be theta. This is your theta, right? Now this is your theta. So this is going to be your g. So g always acts downward. So when g always acts downward, we do not have any acceleration in this x, in this direction, but we have the acceleration in this direction. So if I take the component, so this is going to be g sine theta. This is going to be g sine theta along the plane, and this is going to be g cos theta. This is going to be g cos theta, right? Now, in this case, the acceleration in x direction is going to be plus g sine theta. See, it is in the direction of motion. It is in the direction of motion. Are you getting my point? Okay. Okay. This is plus g sine theta. Understood? And this is minus g sine theta. This is minus g sine theta. Understood? Now see, sorry, minus g cos theta. So now if you observe, see the only difference between bottom to down projectile and top to bottom projectile is in the acceleration in x direction. Okay. Now if you see the top to bottom also, if you see the down to top motion also, y direction velocity initial and acceleration remain the same here. In y direction the velocity acceleration remain the same. So what does that mean? So it means that we are going to get the same t, we are going to get the same h in both the cases. So how come you say that? Array, when there is no difference in velocity in initial velocity in y direction and acceleration in y direction. So if we are doing again also to get the time of flight and the height, we are going to apply the same equation of motion, and then we are going to put the same thing into those equation of motion. So when we are using the same equation, when we are putting the same thing in the equation, ultimately we are going to get the same result. So the t will be the same, h will be the same. So what is going to be the t beta? So t is going to be 2u sine alpha, okay, upon g cos theta, okay, upon g cos theta, and h is equal to u square sine square alpha upon 2g cos theta. Understood beta? Upon 2g cos theta. Is it fine or not? Please answer me. बोलिए, बोलिए. Sir, how we are going to get the range? So I'm not I'm again telling you again to memorize the formula. In this case we can do by the equation of motion in x direction. Okay, don't memorize the formula here. Equation of motion in x direction. Okay. Okay. Now in this case, what is going to happen? So Sx, that is R, is equal to Ux, that is Ux, that is U cos alpha. Okay, plus half Ax is G sin theta. Okay, so I'll be multiplying T here, G sin theta into T square. Is it? Yes or no? Please answer me. Please tell me. Agreed? Right? Wonderful, sir. Wonderful. Okay. Okay. So see, there is hardly any difference in the projectile with inclined plane. This is same only. Let's do one question so that we get comfortable using the formula. Let's suppose we are projecting something from the top of an inclined plane at an angle of 53 degree, and this angle is 37 degree. Okay, this angle is going to be 37 degree. Can you tell me the all the same things, time of flight, height and the range? Can you please tell me that? Time of flight, height and the range. Please tell me this. Can you please tell me this? Same question only like the last one. Very good, she's saying. Neha, what about you, my dear? You said what about the range? What is the range, Neha? What about you, my dear Beta? So guys, also please, I request you to subscribe the channel also, है ना? So that you get the notification and everything. It seems incorrect. Neha, any answer Beta from your side as well? No, seems incorrect again. Neha Beta, what about you? And what about the others also? What about the rest of you? So see how we got to do it. So see, obviously, sir, we are going to get the same TNH that we have got in the last question, isn't it? Isn't it? So see how we have got in the last question, sir, because we use the same formula, we are going to use the values are same. So T is going to be 2u sine alpha upon g cos theta. So this is going to be 2 into 10 sine alpha, that is sine 53, upon g, that is 10 cos 37. Okay. So we are going to get from here, when we are solving it, we are going to get how much? So we are getting 2 seconds. Okay. Now h we are getting, so it is u square sine square alpha upon 2g cos theta. So when we put all the values, okay, that is 10 square sine square 53 degree upon 10 cos 2 into 10 cos 37. So we are going to get it as 4 meter. Okay. Now for r we can always use the basic equation. For r we can always use the basic equation. So what is the initial velocity? It is 10 cos 53. 10 cos 53. Okay. 10 cos 53. What is the time? It is 2 seconds. We are going to do it. Just let's check. Now plus half. What is the acceleration? So here in the case of top to down projectile like this is going to be plus g sine theta, isn't it? So plus g sine theta, that is plus 10 sine theta. So sine theta is sine 37. Okay, into 2 square. Into 2 square. Let's see what we get. So 10 cos 53. So cos 53 is 3 by 5, right? Into 2. Okay. Plus 1 by 2. Now sine 37. So sine 37 is again 3 by 5. Isn't it? Into 2 square. Into 2 square. So here we get 12. Okay. Here we get. So this is going to be 10, 2, 2, 1, 2 and 2. So it is again 12. So we are getting 24 meter. Okay. We are getting 24 meter. Is it fine, beta? Please answer me. So I'll tell you. See, this is our x now, beta. This is our x. This is the x we have considered now. Did we or didn't we? Right? Now, if this is 53, what is the component of it in x direction? This is 10 cos 53. What is the problem in this? This is our x now. And what is this in y direction? So in y direction, the component will be 10 sine 53. What is the problem? We know that the vector is resolved. When it is resolved in any direction, okay, it takes the angle of that so with this. Okay, so what is the problem? I don't understand. I hope it is fine to you now. So this is going to be 24. Now I'll tell you one interesting thing. If you see this case, we have seen this case also now, 53 37. Now in this is coming out to be 12 plus 12 minus 12. That is going to be 0 only. Are you getting my point? Okay, so see, in top to down projectile, the angle, see, the range can never be 0, right? Because you are going to have, see, acceleration here supports the motion. Okay, so it, no problem, she said. So acceleration in this case supports the motion. So R can never be 0. Okay, in this case. Understood? Understood? So guys, with this, projectile motion is finished completely. Projectile motion is also completed. So in the next session, we are going to deal with the relative velocity in 2 dimension. That is nothing, merely we are again going to use these similar equations, the concept of vectors, okay, and the concept of relative velocity. So if you haven't seen the relative velocity in 1D, before you come to relative velocity in 2D session, please do watch relative velocity in 1D. Then only you are going to understand that topic. Okay, so we are going to do the famous, Rain Man problem, river boat swimmer, river swimmer problem, and aeroplane wind problem. We are going to see to it, right? So let's meet in the next session, which is just, I think. So I'll start at after. So I'll start at 5:15. Okay, I'll start at 5:15. I also need a break for my throat now. So 5:15 we'll start. Okay, sounds good. Okay. So guys, in this session, projectile motion is completed. So we will be completing the motion in a plane very soon. Relative velocity in 2D and circular motion is left. We'll be completing that very soon. So guys, with this, thank you very much. Have a good day and wish you all the best. And let's meet each other in the next session. So those who haven't subscribed yet, please do subscribe.